Hello, I'm Rebecca Fiebrink, and today I'm presenting research that was mainly the work of my PhD student Timea Farkas with assistance from Nathan Hughes. Timea and Nathan are now finished with their PhDs and gainfully employed, so I'm presenting on their behalf. Technology has been used in board games for many years, with early examples being Stop Thief, which gave oral cues to players, Dark Tower, which used a microcontroller as a sort of game master, and Clue, which used VHS tapes to offer interactivity. Today, most modern augmented or hybrid games rely primarily on mobile apps. Research on players' experiences of app-supported games reveals a bit of a mixed bag. On one hand, work such as that by Rogerson and colleagues shows the technology serves a wide variety of valuable functions in these games, including offloading and tedious tasks and providing sensory stimuli which can enhance narrative and thematic elements. On the other hand, in a recent survey, just 1/3 of board game players expressed a positive attitude towards games with apps, and many players feel that screens disrupt their gaming experiences. Our work therefore began with the questions, what alternative shapes might augmented or hybrid board games take, particularly if they did not have to rely on apps? And how specifically might these be designed to drive positive player experiences such as immersion? To begin to map out answers to these questions, we ran a study with 31 hobbyist board game players, seeking to learn how they imagined interacting with technology in future hybrid games. We asked people to imagine technical capabilities beyond what might be currently possible, and to think beyond the exclusive use of screens. They were also asked to specifically think about how technology could be used to invoke thematicness. This is a concept that arises out of our own previous research, and it refers to the degree to which the game world feels realized to the player. Like other researchers, we are especially interested in how technology might support board game players in experiencing immersion, which our work suggests can be driven by thematicness. We used a rapid idea generation method called Crazy Eights. Each participant created 8 individual design ideas in 8 minutes, spending 1 minute on each. Specifically, for each design, we asked participants to choose one board game piece, think of a way of interacting with it, which then triggers something in the game which makes the game more thematic. Participants sketched out all 8 designs on a single piece of paper like the one you see on screen. At the end of the 8 minutes, participants joined a short small group discussion and they uploaded a brief written explanation of all of their designs. We ended up with 242 designs. To analyze these, we used a qualitative content analysis approach called inductive category formation. This is a systematic procedure where data is coded line by line, forming initial categories which are then iteratively revised. It uses predetermined selection criteria, which in our case were to extract and categorize what components players are interacting with, how players are interacting with the components, and what effects were triggered by this interaction. Ultimately, we ended up with codes in 42 categories, which were further grouped into 11 higher-level categories. Each of these high-level categories is shown in our paper in a table. For instance, this one shows human-to-object interactions, and this one shows event-based automations. These categories can also be understood as sitting within a larger hierarchy of relationships. Therefore, we also ended up grouping these categories into a taxonomy, shown here and described in detail in the paper. At the highest level, this taxonomy organizes players' visions for how technology could be used as inputs, as outputs, or as processing that determines how outputs arise from inputs. The taxonomy can be used on its own to understand how our participants imagined a space of possible designs, and in principle, you could also use it to generate new designs. However, it's a bit unwieldy and technical. Therefore, we also created the analog-digital hybrid board game ideation deck, a set of cards which provides a complementary representation of the design space. The deck consists of 35 cards organized into 4 groups: interactions, components, technologies, and effects. These cards are designed to be usable by non-academic audiences, particularly board game designers, and to be conducive to design ideation. For instance, they can be shuffled, randomly drawn, matched together, and swapped. I'd now like to share some of participants' designs with you, and give you a starting point for seeing how our taxonomy and cards can be used to describe and ideate within this design space. I'll start by talking specifically about inputs, things that can happen to ultimately trigger some kind of effect. For instance, one participant imagined cards with screens. These could be blank but reveal information depending on where they are placed on the game board. Could be used in a detective-type game, where the card only reveals the information you need if placed in the right place. Here, the placement of a card on the game board triggers some action. We can see this as an interaction between 2 objects, a type of interaction that arises from a player action, so it lives here in the taxonomy. Or we can represent this input using some ideation cards. Specifically, an effect is triggered when a card is placed in a location on the play area. As another example, P20 imagined pieces that respond to the passage of time. The longer you don't interact with them, the more they change or decay, like roads or buildings that break down. In our taxonomy, this is an example of an automated effect which is conditions-based. That is, it's dependent on a timer satisfying a condition. We can also represent this using the timed interaction card. Now we'll discuss some of the outputs, the effects that players imagine technology having. P1 imagined pawns that change temperature as you move them around the board into different climates. This is an example of a sensory output effect. We can also represent this simply with the temperature card. P6 imagined car or ship pieces pulled or pushed apart via magnets to simulate explosions. This is an example of physical components of the game changing, an object behavior output effect. This is one of the possible effects we can represent with the transform card. And P17 imagined that if you place a meeple onto a location, you could hear a spoken story of that location. Here the effect is that the narrative of the game is advanced. We could see this as a game state change, and we can represent it with the game state effect card. Finally, I'll say a few words about the processing that occurs in order to determine what output to trigger for a given input. Often, participants were pretty vague about how this processing happens, but occasionally this was a key part of their designs. For instance, P3 imagines dice for games where when they land, they record the number onto your attached app, so you can't cheat, and the side it's landed on will glow until another roll is made. Here, they clearly imagine a phone or tablet being used as a processing device, as well as potentially other processors living within the dice themselves, so they can know how they're rolled. We can represent both with the Smart Device Technology card. And P29 imagined a game where you need to teach a little robot to move to a goal. The robot uses a reinforcement learning algorithm, and the user can help it learn better by providing obstacles or certain prompts. Here they've imagined a specific type of processing in software, reinforcement learning, and we can represent this with the AI machine learning technology card. So in summary, our study showed that players have some fantastic ideas about how they can imagine technology being used in board games. Many of their designs go far beyond the use of apps and screens. Further, players had lots of ideas about how technology could enhance thematicness, especially by adding sensory elements. We've captured the structure of players' imagined design space in a taxonomy, as well as in a set of ideation cards which you can download with the paper or using this QR code. We hope that this work is valuable to other researchers and designers who share our interest in exploring what new forms games might take and how these could be experienced by players. So, thanks very much for listening today.